Okay, so let us try to compute derive the formula for the maximum deflection for a beam, a simply supported beam with a concentrated load at the center or the midspan. So, wala na siya, no? Karon, imong i-draw ang next is to draw the elastic curve. So downward magina siya, di ba? Okay, downward na po ng force. Okay. So, at first ato sang i-try ang katong conventional ninyo nga pamaagi, no? So kaning kung na-support that is P over 2. Wagi sa tao shear diagram. Okay? So sa katag P over 2, tagan ka, kalay load, down ka. So P over 2 minus P, negative P over 2. That is for the load, the shear, and the moment. Okay, so area P over 2 times L over 2. That is PL over 4. This is 0 degree. This is first degree. Triangular. Okay. So next, wala na itong ibuhat na ito ngayon, ano? Buhat ang tangent line, then atong pangitaon ang, so this is A and this is B, deviation at B with respect to A. Okay, so deviation at B with respect to tangent drawn at A is equal to the centroidal distance towards B, area from B to A. Okay, so centroidal distance dire nato sa moment diretso. That is towards B. So that is L over 2. Then the area is 1/2 times L times height, PL 4. Okay, so that is deviation at B with respect to A. Using your calculator, multiply na mo dito, no? 1/2. Ayaw na ninyong bagtanawa ng mga LL, paulahin na lang ninyo ato lang mga numbers. So 1/2 times 1/2 times 1 times 1/4. That is 1 over 16, or P, pila ka L? 1, 2, 3. So that is PL cube over 16. Okay? TPA pa na siya. Karon by ratio and proportion, let us say this is C prime. By ratio and proportion, deviation at B with respect to A is 2 L proportional to CC prime is to L over 2. So expected magyud na to, no? Now, once nga na ang load na sa tunga, expected na to ang pinaka maximum na deflection tapos sa tunga. Kung asa ni mo i-apply ang load, dito po siya mo bend lowest. Okay? So sa yun ragyod kung ang load ni mo na sa center, pero yung load is at a certain distance from the center, medyo complex na siya kaya pangitaan pa man mo ang distance of the maximum distance kung asa ang maximum deflection. Okay. So since gani pamanta dili lang sa ta, so CC prime is to L over 2. So CC prime is equal to deviation P with respect to A multiplied by L over 2 divided by L. Cancel. CC prime is equal to 1/2 dBA or 1/2 of your PL cube over 16. CC prime is pila? 1/2 of your 1 over 16 multiply 32. Okay. So pamaya itong pangitaon sa paman. Aside sa kani dan kani may lain. This one, deviation at C with respect to the tangent drawn at A. So deviation at C with respect to tangent drawn at A is area from A to C or C to A multiplied by centroidal distance towards C. Okay. So what is the area? Ang area from A to C is 1. Then centroidal distance towards C, X sub C. Okay, so area is 1/2 L over 2 is 1 times height PL over 4 multiplied by centroidal distance, that is 1/3 of your L over 2, so that is L over 2 times 1/3. Okay, so compute. O gyapon ayan ninyo pa na pila ng mga L lang sa mga numbers lang, 1/2, 1/2, 1/4, 1/2 and 1/3. So 1/2 times 1/2 times 1/4 times 1/2 times 1/3. So that is PL, pila ka L? 1, 2, 3. PL cube over 96. Okay, so makuha na nato, no? Saan to? Minus to si CC prime. Minusan na to si CC prime by deviation sa C. So that is deflection maximum, which is at the midspan for concentrated load at the center applied to the simply supported beam. CC prime minus TCA The CC prime is PL cube over 32 minus PL cube over 96. So, pila ang maximum moment? I mean, the maximum deflection. That is 1 over 32 minus 1 over 96. So, that is PL cube over 48. Don't forget the EI. Supposed to be na mag-EI kita rin. Flexural rigidity. Wala na rin. I-move naman na ito speakers. Okay, so this is the formula for the maximum deflection for a beam with a beam for a beam with a simple support, simple support and concentrated load at the midspan. This one. Okay, so now let us try solving the same, deriving the same beam and loading, but with not the conventional way. So, kung niagi, o gaina, nag-draw pa ta o shear diagram. But unsay pamaagi sa pag-draw na to nga wala na shear diagram, diretso na moment. Okay. So kung nakadumdum mo ato sa trusses na to, kung asa ka mag sum up moment, makancel ang katong mga forces na nag-act dito. Di ba? Dumdum mo ato. Sa katong video na to sa trusses, kung asa ka mag-sum up of moment, makancel ang mga loads. So in that way, ma-minimize nimo ang mga unknowns. Okay. So gamiton na to siya nga concept diri sa beams. So kung mo-sum up tag moment, so specifically ang term ana is i-fix nimo ang isa sa mga supports, no? Mo na pamaagi para di na ta maagi og shear. Always na ta load, moment, moment, load. Okay, mo ra magila tong ginabasihan permi ang moment, ang area sa mga moment, distances sa centroid sa moment. So moment ug load ra gyud sa theory. Basically. So, okay. Gihapon tay sige tawagan the elastic curve. We also still have the tangent line from A. Actually, pwede nyo balihon ha. Pwede na mabalik, pwede ka diri sa B. Depende kung asa ka mas convenient. Pero ako, medyo naanad lang ko towards, kaya ang handwriting may nato towards the right. So, towards the right ako. Okay. Magyapon nga concept, but wala na kaniagi o diretso na ta M over AI. So, saan man? O gyapon ko ano mo si Derivation B with respect to A nga dire C prime kani deflection max. This one is deviation at C with respect to A. This one. Okay. So, ang technique is to make the other support fix. Dito ka mo sum up of moment. Okay? Dito ka mo sum up of moment. So, kung sa man nga mga forces, so So ang akong na illustration is to like this one, fix. Dumdum mo nung fix. Ano na fix? So i-fix na ko diri. Diri ko mag-summation of moment. So makancel sa nako ang load or ang reaction diri nga part. Mas convenient para sa kuha usually na kung asa ko mukuha og dako nga deviation, dito ko mag-fix. Later masabtan nato na pag drawing na nato. Kaya nga naman, kung makuha kag centroidal distance, usually the shortest route or shortest distance na padulong sa dako nga part. Okay, so like this one, pilay reaction dire, that is P over 2, that is half of your load distributed at the supports. So if you sum up moment at B, because you fix at B, so the rotation P over 2 will cause a moment at B with a distance L. Okay, so unsa man na siya, kung once nga inani ang imuhang load, ang imong shear is 0 degree pag concentrated load, di ba? This one, 0 degree, first degree. So automatically ang imong moment should be in the first degree, which is triangular. So this one is triangular, a positive moment. So a positive moment, by the way, is it tends your beam to curve downward, which is the usual bending of the beam. Mo na positive na moment. Maglibog mo ba anong positive man na siya, diba? Kung nag-ana ka diha beam, napay rotation diha the beam will tend to go downward. Kung makakos ganing mong moment of downward nga deflection, that is a positive moment. But for the case of P, sir, downward man siguro ni dili. Kaya kung mag-cut ka, example diha say for example mag-cut ka at the midspan, the load P will cause a concave upward nga bending, no? Pag-down mo ang concave upward siya, so that is a negative moment. That is not the usual bending for a beam. Mo nang ang basihan nato. If ang usual bending ang ma-attain, that is a positive moment, which is a downward bend. But if it is a upward bending, which is not the usual bending of the beam, that is a negative moment. So this is a positive moment, which is P over 2 times L. Okay, so that is PL over 2. What else? We have the load P. Project ni mo diha, that is concentrated load. Then the load diagram is 0 degree. Then the moment diagram is first degree, which is triangular. So that is P times L over 2. This is L over 2. No? So that is, actually this is negative PL over 2. Okay.